427. And in question 4, page 427, at the bottom of the page, they talk about an angle in standard position. Wow. There we go. An angle in standard position, and it's very important for this unit that we define this clearly. So an angle in standard position will always starts at the positive x-axis. And the reason we have a standard position is so that when mathematicians talk about something like 100 degrees, everybody knows what they're talking about and what it looks like. So if I would say, draw an angle of 100 degrees, well, in standard position, you would start at the positive x-axis. 100 degrees would go past 90. So this would be 100 degrees in standard position. It has to start at the positive x-axis, and every positive angle goes counterclockwise. You could have an angle in standard position that's negative, right? I could go this direction, and we would call that negative 70 degrees. So angles in standard position start on the positive x-axis, and what we're going to be looking at in grade 11 is angles from 0 all the way around to 360. And then in grade 12, they say, well, you don't have to stop at 360, you could just keep on going. And then here, what they've done in the diagram is they've put a point, and if you would draw a straight line down from that point, you would get an x-coordinate and a y-coordinate. And what they've done is they've changed the x-coordinate and wrote it with cos and sine. So for example, I could use my trigonometry, my SOHCAHTOA. Can you see that you could say that sine of theta is the opposite over the hypotenuse? So in this picture, it would be y over r. And if I wanted to get y by itself, I could multiply both sides by r, and I would get my y-coordinate is r sine theta. Similarly, I could write that cos of theta is the adjacent, which is x, over the hypotenuse, which is r, and I could get, by multiplying both sides by r, I could get my x-coordinate by itself, and it would be r cos theta. So they're saying that no matter where you put a point on that terminal arm in an angle in standard position, the x-coordinate will always be r cos theta, and the y-coordinate will always be r sine theta. So let's go to example 1. So they're telling us that the point 3, 4 is on the terminal arm of an angle in standard position. So we could draw a picture of this. 1, 2, 3, 1, 2, 3, 4. Here we have the point 3, 4. If that's on the terminal arm, this is where the angle ends. Standard definition means it always starts from here. Here is our angle theta. And we are in a trigonometry unit, so every time you're given a point like that, you can draw a triangle. Can you see that if I go straight down to the x-axis, I would make a triangle where this side is 3, this side is 4. And if it wants us to find the distance from the origin here to the point P, well, then you just have a squared plus b squared equals c squared. So we would have 3 squared plus 4 squared equals c squared. Does anybody recognize this triangle? It's like the most famous right triangle ever. No? The reason it's the most famous right triangle ever is because if I do this, 3 squared is 9, 4 squared is 16. It works out beautifully, once you square root both sides, that it works out to 5. So it's the most famous right angled triangle because all the numbers are nice. It's called a Pythagorean triplet. There's a bunch of Pythagorean triplets. This is just one of them. But the 3, 4, 5 probably is most helpful because in construction, when you build walls, you want things to be at 90 degrees. So one of the ways they check if it's 90 degrees is they make a little measurement. Maybe 3 feet, 4 feet, mark the points, and if they measure between the points and it's perfectly 5 feet, they know that their angle is 90 degrees. You can buy metal triangles, and they usually are 3 units this way, 4 units this way, or some multiple of 3, 4, 5 for measuring. Next, a new definition. The primary trig ratios. Well, it's not really a new definition, but what do they mean by that? They mean all 3 of the ones that you know from SOHCAHTOA. Sine of theta, cos of theta, and tan of theta. And when they're asking for the ratios, they're just asking for the definition. Sine is what over what? Sine is opposite over hypotenuse. It would be 4/5. Cos, adjacent over hypotenuse, 3/5. And tan, opposite over adjacent, 4/3. And so if you wanted to find theta, you could use any one of those. Okay? So let's say if I use sine, then I would have to do sine inverse of 4/5. If I did cos, I would do cos inverse of 3/5. And if I did tan, I would do tan inverse of 4/3. I'd like you to type all 3 of those into your calculator just to see that it doesn't matter which one you use, that you're going to get theta equals 53.13. The question asked for the nearest degree. So it would round to 53 degrees. And I've got a bunch of questions that we can start practicing right now. 3, 4, 5, 8, 9, 10, and 12.